Hello, Shravan. Shravan, I cannot hear you.
Hello,
Hello?
hello. Yeah, can you hear me?
Yes, now your voice.
Okay,
Yes, now I can hear you.
okay, fine. Could you all hear me? Hello.
तो नहीं आएगा रजिस्ट्रेशन करने के बाद
Hello.
तेरे पास
Hello, Rajiv sir, can you hear me?
ना क्या हुआ है
Hello.
देना
Hello.
क्या चल रहा है ये कुछ सुनाई नहीं देता
Hello. Hello. ओपी नेट स्लो आ रहा है क्या? बड़ा डिस्टर्बेंस आ रहा है उससे तो और हेलो, आर यू गेटिंग माय वॉइस?
यस
Okay. Nirjar, can you hear me? Okay. Okay, then we'll start the presentation. So, this NetSim is wide range of technologies like LAN, WAN, wireless, cellular, cognitive radio, LTE, and sensor network as per their international standards. Now it has a open architecture with protocol C source code where users are provided with C source code of network protocols which are implemented on IEEE and IETF standards. The purpose of giving this C source code is to enable users to edit the standard protocol code according to their own implementation, and they can link it with NetSim and analyze the performance of the newly designed protocol. Okay. Now NetSim has different customer segments like enterprise, defense, R&D labs, academic. So in enterprise, they use for network designing, network validation. Then in defense, they use for network-centric warfare. Then R&D labs, they use for protocol development, new technology testing. And in academic, they use in network labs in BTech on MTech. Then in advanced network lab, they use in MTech and PhD thesis for their projects. Okay. Now this architecture is of NetSim, where you will give the internal view of NetSim, where users will design the network and configure it in GUI interface, which will be further simulated by NetSim engine and thereby provide multiple metrics regarding performance of the simulated network. Okay. So user is not required to write any script or code while designing and configuring the network scenario. Okay. So there is one feature of NetSim is the NetSim engine itself. As you can see, it is utilizing a virtual network stack, which actually mimics the real world TCP/IP stack, and
Welcome to the webinar.
hence make it very easy for any user to edit protocols and also get fairly cheap licenses. Further, user can also perform research. Okay. Now, in NetSim, there are some components. It is divided into some modules or component, you can say. In NetSim, there are two versions. One is academic version and one is standard version. So, in academic version, you have all the components with all the modules, and you can use it in GUI. Okay. But in standard version, you have option to choose this among these components. So you can choose whichever technology you want to use, and you can choose from here. And there are custom code facility which is exclusively available in the standard version only. So for research, we prefer for the standard version. So here we can see component one is the base component required for all the components. So it has internetworks. So it has internetwork which is having Ethernet, fast and gigabit, ARP, wireless LAN, then which are of 802.1, AA, BG, and all the standards. And propagation has free space, long normal shadowing, relic feeding, then firewalls, routing, RIP, and OSPF. Then queuing is there, and there are some common module application which can be generated over one node, like voice, video, FTP, database, HTTP, email, peer-to-peer, and custom. So these are the common module application which can be generated on any node. So component 2 is there, which has legacy network like Aloha, pure slotted Aloha, CSMA CD, token ring, token bus, ATM, then frame relays, MPLS, and all these are designed on the as per the international standards like IEEE and IFC. Okay, and component 3 has BGP network, border gateway protocol, and component 4 is advanced wireless network, that is MANET or WiMAX, and MANET has DSR, AODV, OLSR, ZRP protocols. Then component 5 has cellular network. Cellular has GSM and CDMA both. Then component 6 is having wireless sensor network and personal area network with agent model and battery modules with ZigBee. Then component 7 has cognitive radio network, which is having WRAN. And then component 8 is having long-term evolution LTE module. Then component 9 is having military radio, that is TDMA link 16. Okay, so these are the components which are having in this NetSim software. So now, what's new in V8? So in the latest version of the NetSim, we have added some features. Like in LTE, we have added OFDM for downlink, then SCFDMA for uplink, then MIMO for enhanced throughput. Then in dynamic metrics, we have given some graph metrics of application throughput and link throughput. Okay. So in UI property view, you can custom some properties into the nodes, devices, and BGP and cellular metrics is there. Then some new application models are being added, like peer-to-peer, email, and HTTP. Wireless radio area network WRAN is this. So now NetSim hands-on. So NetSim hands-on is divided into two parts. One is in model simulate analyze of a variety of network, and one is write your own code and link it with NetSim. Okay, so we'll go to the part one where we design the network. So we have various nodes and links given in the software. So we choose to click those nodes and drag and drop into the environment of the software and connect it with links and create a network. After that, we configure the network. In configuring, we just open their properties, node properties, link properties, and configure the network, set our parameters. Okay. After configuring, we model the traffic. On any node, we can generate various kind of traffic, as I told you, that like peer-to-peer, custom, CBR, many type of packet we can generate on any node. So after that, we can simulate a network, so that after simulation, we can get our data. In part one summary, we can see in this screenshot that some nodes and links are connected to have a network here. And in application tab, we are seeing that application types are given: CBR, custom, email, HTTP. All these are provided to generate traffic on any node. You can right click on any node and do the custom. Then I've told you that it can be open in command line access to simulator or XML based config files. So XML is very easy to understand and have better representation. So we prefer to use in XML because when you use in GUI, it will automatically create an XML based configuration file. So that is more understandable and easy to use. Now analysis. Analysis has performance metrics. After the analysis, you will get a performance matrix in which you have various kind of metrics like network metrics, protocol metrics, and device metrics. Then your protocol metrics. All these metrics you will be having after the simulation. I'll show you further. And this packet animator is there. In packet animator, after the simulation, you can see packets moving from one node to another. Your data packets in animation. So in analysis summary, I've told you that it create a protocol performance metrics in both the versions, in standard and academic both. Then in performance metrics, there are network metrics, application metrics, link metrics, protocol and device metrics. Okay. So I just metrics. It allows user to view the values of the metrics obtained based on the overall network. Like you can see the detail of the whole network throughput. Then in application metrics, it displays the various metrics based on the application running in the network scenario, like throughput, delay, and etc. Then link metric displays the values of the metrics related to each link, like packet transmitted, packets errored, and collided. Okay. Then in protocol metric displays the protocol-based metrics which are implemented in network scenario. And metrics will vary depending upon the type of network simulated. In this case, you can notice TCP metrics, IP metrics, and OSPF metrics, okay, which are common. So in device metrics, it displays the device related to metrics like ARP table and IP forwarding table. So these are the various metrics that will generate after a simulation. And this is the screen of performance metrics that you will get after the simulation. Now packet animator, it is also available in both the versions. Here you can see in screenshot, some packets are moving from one node to another. It will flow from this network to this network, and you can choose to increase or decrease the animation speed from slower to faster. So so these are the analysis which are available in the standard version only. So these are traces. Okay. So traces are of two types. One is packet trace and one is event trace. So this packet trace, it creates a set of chosen parameter for every packet as it flows through the network, such as arrival times, queuing times, departure time, payload, overhead, or all it will be shown in the CSV format. I'll show you in the experiments what are other parameters we can show. And this event trace, you will have it will record every single event along with associated information such as timestamp, event ID, event type, device ID, and protocol name. And this is used for performance validation, statistical analysis, and custom code debugging. So these are the traces you will find after the simulation. Now dynamic metrics. Dynamic metrics allows you to have some dynamic graphs of link throughput and this application throughput. Okay. Then some TCP congestion graph can also be dynamically plotted. After this, Wireshark. So you can see, as you know, Wireshark is a free and open source packet analyzer, and it is used for network troubleshooting, analysis, software and communication protocol development. Okay. So in NetSim, instead of performing some mathematical calculation and providing the result to the users, it actually generates the packets and transmit it within the simulated network. So Wireshark can be used inside NetSim to capture these packets at multiple node location and perform further analysis. So when you enable this Wireshark on any node, so it will automatically start during the simulation, and after the simulation it will show you the results of Wireshark, and some graphs like RTT graph, window scaling graph can be generated afterwards. Now part 2 has development platform, in which we can develop our protocol, or we can change something in existing protocol. So it is a feature which is available in standard version only. So you can see in some screenshot, there are two screenshot. One is in programming, one is in GUI. So in programming, there is a box made. Here we have changed something like printf hello world. So we have printed one command like hello world. So after building it, it will link it through GUI and show you the result that you have changed in the DLL. That I'll show you how to do it. You can see some these custom code in your installation directory. See program files in NetSim standards. When you install NetSim software, you will have this installation directory. Now NetSim provides some APIs for protocol developer. So in order to reduce time and effort of protocol developer, it provides some APIs that can use to perform activities like packet creation, deletion, IP address comparison, and many more. NetSim also provide a manual in the help section to assist developers while writing or editing the source code. Okay. So now NetSim has a 300 plus customer base across 15 countries in different domains like defense, space, industries, education, international, and India both. Okay. So now after the presentation, we just start with the software part. When you open this software, this is the first window you will see, and there are some tabs given here like simulation, programming, utilities, and help. Okay. So in help, you will have user manual, source code, experimental manual. These are in PDF. You will also get the hard copy when you purchase it. And in simulation, in new, you will have internetworks, in which you will have Ethernet and wireless network, where you can design LAN WAN. Then legacy network has pure Aloha, slotted Aloha, traditional Ethernet. All this technology you can design in legacy network. Then advanced wireless network, it has MANET and WiMAX. Then BGP network, cellular network, GSM and CDMA both, wireless sensor network, then personal area network, ZigBee, cognitive radio network, and LTE network. Okay. So you can choose any of the technology from here and show the result. Like I'll just show you one scenario of CDMA today. This is the software for software environment you will get after the opening this technology, and you'll see some nodes are given here and some features, parameters. So some nodes are disabled here. Actually, these are the nodes which are related to other technologies like wireless sensor network, this is wireless, and the nodes are also disabled because these are of different technologies. So only mobile station is enabled, so we can use it in CDMA network. So first you have to drop base station in the environment. Okay, and one MSC switching unit. Then you can connect it with wired link, and for connecting this mobile station you can choose just click on the environment and the mobile units will automatically get connected. Okay, so this is one network of CDMA network, and when you want to do some changes in properties, you'll have this right click properties, then go to global properties like device name, device type, this position. Then you can change the mobility model like random walk to no mobility, or you can change the speed of the node also, velocity. Then in interface CDMA, you will get the data link layer and physical layer parameters. Here you can change the transmitting power, and there are some information tabs given here. When you click on any information tab, you will get the information about those features. And in this parameter, you will get the information. Connection medium, IMEI number, MAC address. You can click on, you will get the MAC address detail. Okay. So this is the feature for device. Then for this base station, you will have the global properties, interface CDMA, which data link and physical layer is there, and some parameter like protocol standards are given here, total bandwidth, chip rate, BTS range, then voice activity factor. So this voice activity factor is the feature that will change further. Actually, when we decrease this voice activity factor, the channel count will increase, and also the when you decrease this voice activity factor, the call blocking probability would also get affected and it will decrease. So we'll see those changes further by changing some parameters here. So when you accept it, and when you have to change something, you have to go to the application, right click. You can choose to give application further here, like you can choose source to destination. Then you can see some codec value you can change, packet size constant to exponential, and packet size, inter arrival time you can change, call duration, inter arrival time, IIT distribution, service you can change from CBR to VBR, VBR to CBR. Okay, your application type is call, Erlang call. So actually I've made it already, so I'll just show you an example. So because we have to change many of the parameters, so I'll show you an example where I've done all the parameter fill in CDMA. When you open it, here you can see we have created one network by having a base station and switching unit, and and attached 20 mobile units here. Okay, 20 mobile units, and this green sign shows from data flows from one node to another. So we have chosen 10 application types. Okay, properties. So we can choose 10 applications are given. 10 application 1, 2, 3. In every application we can see source ID is 324, and the parameter is packet size is constant, packet size is 33, and duration 60, interarrival time is 10. Okay, and application 2, all the parameter is same, we just change the source and destination 5 to 6, then 3, 7 to 8, 4, 9 to 10. Like this, in application tab, we have added 21 to 22. So one by one, it is sending data from one node to another. So we accept it. In properties, base station property, we see voice activity factor is 1 only. Okay, so after simulating this, we keep on changing this voice activity factor from 1 to 0.8, 0.9, 0.8, 0.7 up to 0.1 and see whatever changes are happening. So we just accept it. And also, I've told you that it has the standard version has some features of packet trace, event trace, and dynamic metrics. So we have to choose this packet trace. If you want to generate packet trace, you have to give the packet trace name, packet trace, and file type would be CSV, Excel format, this storage path, and these are the attributes which will be generated after the packet trace. And event trace, you have to give the event trace name. These are the attributes. Now in dynamic metrics also, you can choose plot graph after simulation, during simulation. So we choose plot graph after simulation because it will slow down your simulation. So link matrix and applicant matrix are given here. So just choose OK and run the simulation for 100 seconds. So graphs are being generated. So here you can see performance metrics. As I told you that after the simulation we will get this performance metrics where we will have the network metrics, link metrics, queue metrics, IP metrics, cellular metrics, application metrics, application throughput. So all this information is given. In network metrics, you will have the information of the whole network, simulation timing, packet transmitted, error collided, bytes transmitted, payload transmitted. All these details are given for the whole network. Then link metrics has the information about the link, queue metrics, IP metrics, IP forwarding table. The the main metrics we'll see in this cellular matrix is cellular matrix, which has MS matrix and channel matrix. So channel matrix will analyze according to the channel matrix only, because we have chosen the one as the voice activity factor. On one, channel count is 3. Okay. So afterwards decreasing those voice activity factor, this channel count would increase. So I'll show you after decreasing those voice activity factor. And in MS matrix, when you combine all this call blocking probability, you will get the detail of the overall call blocking probability of the network. Okay. In link throughput, you will have link 1 for wired network, link 2 for wireless. This is the graphs of link throughput. Okay. Then you have chosen the open packet trace and event trace. So just choose open packet trace here. And you can see the packet trace in the Excel format. See, these are the details of packet trace. Okay, here you can select this top row and freeze the panes, freeze top row, and also filter it. Okay. So the benefit of filtering it, you can get the each and every packet detail. Like if you select packet 1, you can see only packet 1 detail will be seen, and after this you can see the application type, that is source and destination, then transmitting receiver details, then its parameters, throughput, then whether it is successful or not, packet is successful. Okay, so you can choose to have each and every packet from here. Likewise, you can choose 3, 4, 5. So we'll get the packet detail of those packets only. So this to analyze packets. Like this, we have event trace for each and every event performing in the network. So likewise, you can also filter this and see each and every events performing in the network. For every event, you can see. Okay. You can see the packet animation also. If you play it, it will show you the packets moving from one node to another. So you can choose the speeds from slower to faster to see the animation faster. If you increase the simulation timing, you can see the movements also. The nodes are changing their positions. Okay. So we just close it and go for the further analysis. Now we just save this experiment and see one more feature, that is NetSim Analytics. When you click on this, you will get this window, Analytics. Here we choose cellular networks and browse some metrics here so that we can compare those metrics. Like if we choose CDMA, various CDMA metrics. So we have chosen 4 metrics, and these 4 metrics can be compared by having these parameters like simulation timing, packet transmitted, packet errored, packet collided, bytes transmitted. So we can see the comparison between them. They're having various different parameters, so the result would be different. Payload transmitted, overhead transmitted. Okay. So likewise, we can compare between different networks. So we were analyzing the voice activity factor, which affects the channel count. So I'll just show you one more example where I have reduced the voice activity factor to some extent, and it will show you the effect of channel count. So it is having the voice activity factor of 0.6. I've reduced it to 1 to 0.6. I've gradually reduced it, but I'm showing you one only. So 0.6 is there. So now we can see how this will affect the channel count. So after the simulation, you will get performance metrics. It will same according to the previous experiment. We will see only the cellular metrics in which channel metrics is there. So we can see the channel count is increased from 3 to 5. Okay. So likewise, if we change this voice activity factor, you will get a graph like this. I'll show you this one. This is a comparison chart between channel count and voice activity factor. So here we have decreased channel count from 1 to zero point 0.9, 0.8, 0.7, 0.6. Okay, to 0.1 up to 0.1. So as you gradually decrease this voice activity factor, it will increase the channel count from 5 to 10, 15, 20, 30. So this is what we want to analyze. And one more thing we can analyze here, we can see the call blocking probability. If we add the call blocking probability and plot according to this graph, decreasing from 1 to 1 to 0.1, it will decrease the call blocking probability also. So we'll see in NMS matrix when we add this call blocking probability that we can plot the graph afterwards. So these are the call blocking probability given here. Okay. So this is about CDMA network where we can analyze voice activity factor over channel count and call blocking probability. Now I'll show you how to change a protocol in Visual Studio. Okay. So for having the source code, we have to go to the installation directory of NetSim. Here we can see some folders are given: bin, docs, and src. In bin folder, all the protocols implemented in the NetSim are given here in the DLL format. So the NetSim accepts the DLL format only. If you want to change anything in the DLL, you can go to the Visual Studio and change something and build it again. And you can place those DLL into this bin file, and also you can choose to rename your default DLL to some another name, so that your original DLL would not get affected. Okay. So in src simulation copy, you will have a link called NetSim. When you open this Visual Studio window will open, this one. So here you will get the protocol programming of all the protocols given here. Okay. And I have opened one protocol called dsr.c file I have opened, and in the init function of the dsr, I have added one command called printf hello world. Okay. So when I built it and create my own DLL, this hello world would be printed when I implement it in MANET or wireless sensor network, any kind of network which calls the DSR protocol. So I have already built it, and it has created in the DLL folder, that is libdsr.dll, and also I have already copied it into the bin folder. Here you can see libdsr.dll and libdsr default DLL. So default DLL is the original DLL file which is already having in the NetSim, and this is the libdsr.dll which I have made in the Visual Studio and created it. So when I call the DSR function, it will call my dsr.dll. Okay. So I'll show you in the experiment where I'll call the DSR function. This is the MANET. There are 5 nodes, and in application I have added 1 to 5, source as a 1 node and 5 destination as a 5 node. CBR type of packet is being generated. Packet size is distribution is constant and value is 1460. Interarrival time is constant and values is 20,000 microsecond. Okay, I'll just accept it and simulate. For 50 seconds, when I simulate it, then CLI window will come and it will print my hello world statement here. I have added hello world, so it will first print hello world, then when I press enter, then it will simulate my network. When I enter it, it will simulate my network as it does normally. So you can see packet animation. So this is just to show you that we can change anything in the protocol and do some changes. We can also choose the speed of these nodes, increase or decrease, so that the position would differ. Okay. So this is all about the NetSim software, where I've shown you the presentation and the software flow, how we can work on this and how we can change the protocol in any network. So if you have any query, you can ask me, or you can mail me your query. If you have any query here, you can ask me. Hello? Yeah, could you hear me? Your voice is not coming, sir, clearly. If you have any query, you can ask me, sir. Hello? 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 Do you have any queries? Yes, sir, we have set up experiment. Mayur, sir, can you hear me? Mayur, sir, I'll show you. The experiment list is there. This is the experiment list only. Do the experiment list. This is the experiments. 1, 2, 23 experiments are given with different on different technologies like routing, queuing theory, wireless LAN, TCP, internet networks, cognitive radio, then cellular networks, Zigbee, all these networks, LTE, all these are experiments which can be performed. Okay, and it can be opened from here. User manual is also there, source code help, experimental help. Sir, Mayur sir, difference between these two versions is I've shown you in the presentation. That some protocol, some features are only available in the standard version, like packet trace.
Shravan, hello.
Yes, yeah, yeah,
Okay,
Nirjar.
is it about academic and standard version
Yeah,
difference, right?
yeah. They're saying the difference.
Okay, just open the user manual.
User manual. Okay.
Mhm.
User manual. Yeah.
Go to the 1.2.
1.2. This one.
Hmm.
Okay. Okay.
So
So
the main
my
difference in I'll be seeing this. So
okay.
the main difference in academic and standard version is academic version is for students who are going to learn networking for the first time. So for them to make it easy, in academic we'll have program exercises and the simulation is also there. But standard version is for users who are researchers, protocol developers, who will be editing the protocol, will be analyzing the protocol in depth. And for this reason, in standard version, you have some deep analysis features like Wireshark, packet trace, event trace, dynamic metrics. An academic student will not be doing in-depth analysis in NetSim. Hence, all these four analysis features are not present in academic. Students can just analyze a network, but students cannot edit the protocol in academic. Whereas in standard version, the researcher can edit the protocol and analyze the performance of the edited protocol in NetSim. So these two are the main features, main difference rather.
He's asking about the packet trace and event trace also. So
Yes,
I
as
have
I
to,
said, packet trace and event trace are used for in-depth analysis. Just a minute, packet trace, event trace, what they are, or what is the question?
question is this packet trace is available in the academic or not? So I've told them that it is not.
No, no, it's not available.
They're asking one more thing. The PG level experiments are also there. Some in our
Yeah,
experiment.
it is there.
Some PG level.
Experiment manual, some experiments are PG level, but if requested, we can provide them their according to their syllabus because
Okay.
every university has a different syllabus. So
Yes.
based on that, we can provide them
Okay.
PG level.
Okay. For PG level, we can provide the manual according to their syllabus.
Yes,
Okay.
yes, exactly.
Okay. Okay, Mayur sir. Any other queries? Okay. Yeah, Dr. Bhaumik, can you hear me? Margil Shah sir, can you hear me? Okay, then we'll leave this session. Thank you very much for attending, sir.